Okay, let's see how we can calculate a request to connect to the server and receive the server response. This was shown in this slide. Let me show this. Okay, so this is my client right here. This is my server. Now the client starts the session with the statement socket client equal new socket localhost 4450. So it wants to the server will okay, let me just oops. Okay, the server wants to open a socket and wants to connect to the port on the server, which is this guy here. This this blue thing here. This is port number 4450 for on the server side. Now, the server or the client will initiate once it starts the statement client equal new socket. It will initiate a TCP/IP session. It will create a message called request to connect, which is this guy. And then over the link, the Ethernet link or the Wi-Fi, it will send the request to the server. So the server here will receive the request to connect, and the server will start processing. It will process this statement. First, it will receive it through the Ethernet port or the Wi-Fi port, and then it will proceed to send the message back. And this time here, this is a time that the server needs before it can send the response. Here is the response. Whoops. The response, which is this guy, this line. Let me put it in thick so we can see it. All right. So this thick line is the response that the server sends to the client, and the time it takes to send this request is actually called the propagation time. So let's break this down into more details so we know exactly what happens. So now I need to go through the calculation. This is a table. Here is the statement which I mentioned earlier. Client or the socket client, the name of the socket is client, new socket. Here, let me change this from localhost to some address. This address, let me call it 78.56.32.5. I just created this IP address to show that the server is located at a far distance. It's about 1 kilometer from the client. So let me go back to the slide here. So the distance here, okay, the distance from here to here, I am assuming this distance is 1 kilo, or it's 1,000 meters. That's the distance between the oops. The distance between, can do that, between the client and the server is assumed to be 1,000 meters. So let me go back here. These are the tasks that the client will do before it sends the request to the client, to the server. First, it creates a port on the client side. Now this port, the port number here, it will be chosen by the process, by the client class when it's executed. We still don't know what port is that. However, there is a method to find out what is the name of the port. It will initiate a TCP/IP session. Note that this create a port, this is only it's a CPU time a few cycles. I assume it's about 10 microseconds. That's not big deal. 10 microseconds, it's very low. It could be much less, but this is my assumption. To do the TCP session, again, it's about 10 microseconds to process the statement, and then there is waiting time until the TCP, if the TCP is busy and there are many clients who want to create TCP sessions, maybe you have to wait. But here I am assuming there is a zero wait time. You can assume based on the how busy the server is, this could take much longer than zero. Now, I have to initiate the request to connect message. I have to form a message, and this message, again, it's called the request to connect, and it's only a CPU time. Also, this CPU time, I should have done it as 10 microseconds also. I forgot to do that. And also now I have to deliver the message, which is the message is request to connect. I have to deliver it over the network card, the Ethernet or Wi-Fi. This is called the transfer time. This is not the propagation time. This is the time it takes the card, the wireless card or the Wi-Fi card, to or the Ethernet card, to take the message, which is request to connect. And I assume that this message is the message size is 800 bits. Let me put it here. The 800 bits means there are 100 bytes, and each byte is 8 bits. So the total size of the message is 800 bits. Those 800 bits, we need to take them from the memory of the computer through the Ethernet card and put it on the line. It has to go through the physical line. This is a time. This is called the Ethernet transfer time. And this time is, how much is this time? This time is 80 microsecond. Okay. Okay, so this time is 80. How do I calculate the 80? I will show that in a second. It's actually, you take 800 bytes and you divide it by 800 bits. You divide it by the speed of this is bits, 800 bits. You divide it by the speed of the card, which is 10 megabits per second, 10 million bits per second. That's how you find the time it takes to transfer 800 bits. So it's 800 divided by 10 megabits per second. This will be, and I will take this out, this is not right. This will be 80 microseconds. You divide this and you translate the seconds into seconds, into microseconds. You will find that this is 80 microseconds. Now there is a propagation time. This propagation time is the time it takes the 800 bits to go on the physical line. Let me show you here. This is the time it takes over this line. Okay. This is the line. Let me put it in red. Okay. So this time to go from the client to the server is called the propagation time. And the propagation, it's very fast. It goes at the speed of light, because those are the electronics running through the cables or through the Wi-Fi. And the speed of light is 300 million meter per second, or 300,000 meter per second. And I am assuming that the distance is 1 kilo, which is about 1,000 meter. So I will divide 1,000 divided by 300,000. This is how I calculate this. And then this will become 3.33 microseconds. At the server side, now this I already sent the data from, let me take this. So now, okay, I have sent the message from the client to the server. Let's see what happens at the server. So this is the time. 10 microseconds to execute the statement, 10 microseconds to initiate the TCP session, 10 microseconds to create the message, 80 microseconds to transfer the data over the Ethernet card, 3.33 microseconds to transfer the data to propagate it over the line from the client to the server. Now, on the server side, I have to receive the request at port number 4450, and again, receiving the message, it's actually transferring the bit, taking them from the line and putting them onto the port. So here I have this line, if you will. I will make it, now this becomes straight. Okay. So here I took the data from the line, I put it on the port. So this, let me do the following. Oops. Okay. Data goes to server socket. Okay, so the data goes to the server socket and it takes 80 microseconds. This is very expensive time. This is the most expensive time here because the Ethernet card runs at a speed of 10 megabits per second. If the Ethernet card was running at 100 megabits per second, then this will be reduced to 8 microseconds. If I was doing it at 1 gig, it's 1 gig card, then it will be 0.8 microsecond, almost none. Then I will have a CPU time to initiate and accept message. Now I have to respond to the client, so I need some time, and there is a waiting time for the TCP session to respond. I assume this is 0, the server is not busy. If the server was busy, then this could go into several microseconds or even milliseconds. And then the message, the accept message, has to go back to the server. So let's do it this way. From here. Actually, going back to the client. Okay. So this message will have to go back to the client, and so I put it on the Ethernet. It takes 80 microseconds, assuming that the message size is still 100 bytes. And here, of course, let me put it this way. Okay. It takes 80 microseconds to put it on the line, and it takes 3.33 microseconds to propagate through the okay. Just so that we can see that. Okay, it takes 3.33 microseconds. Why? Because I divide, remember here, this is what I will do. It's 1000 meters divided by 300, 1, 2, 3, 4, 5, 6. Actually, let me put this in a box. That's better. Okay. All right. Oh. It's 1000 divided by 300, 1, 2, 3, 4, 5, 6. Okay. So the time here, this is how I calculate, and this is equal 3.33 microsecond. Okay. So I'm done now oops, I have to, one more thing. Once I do that to the client, let me change the direction since I have a client here. So I'm going to the client, and from this client, the client now again will receive the message. The client will receive the message, and once it receives the message, it will have to process the 800 bits that it has just received over the Ethernet, and again it will take the 80 microsecond. And this again, let me show you how the 80 microseconds we have received them. This will be 800 bits divided by 10, 1, 2, 3, 4, 5, 6, 10 million bits per second, which is equal 80 microseconds. Okay, so this 80 microseconds, this is how we got them. And once I go to the client, I receive the 80 accept message, and then the CPU will process the message it has received, so that it will wake up, call it, let's put it this way here, so you could see that it's to wake up the client that has been waiting for the message to come. Let's say it takes 10 microseconds. Now do the calculation. I think probably I have made a mistake here, but let's do 10, 80, that's 90, 100, 180, 260, 270, 80, 90, 370, 376.66. Oh, I think I'm correct. Okay. That's how we calculate this time. Now for your own benefit, I made the calculation here on the slides. This is slide 1 on the client side, exactly what I have just explained. And this is the second type at the server, and this is the return at the client. This is how we do the calculation. And this is of course, the time here. All right. And now I think you can answer the assignment for the